All right, good morning, everybody. We are going to talk today about karyotypes. We did a little bit of this before the break, but I just wanted to create a video to kind of go back and reiterate what it is and why we use them. So, a karyotype is designed to analyze the chromosomes that are in a cell. Usually, we use mitosis. We look at skin cells or something like that because all of our cells in our body, whether they, in the mitosis realm, will have the same number of chromosomes. They're arranged in homologous pairs, so aka the one you got one from mom, one from dad. These pairs are placed in descending size, meaning the first chromosome will be the largest, the last chromosome, number 22, will be the smallest, and then we have the sex chromosomes, and they're placed at the end. And it really is just a picture of how these are arranged, and we can tell if there is a genetic abnormality or something like that. So, once again, as a result of haploid sperm cells and fertilized egg, so we got 23, 23 coming together to make 46 for a normal old human. All right, and that's what we see. All right, guys, so here's a normal male karyotype. 46, sorry about the little lines. You can see here we have, this is our X chromosome, this is our Y chromosome. The Y is significantly shorter than the X, and that's okay. That's perfectly normal. But you can see here we have 2 per pair. No abnormalities, just 2 per pair. And here's a normal female chromosome, our karyotype. Once again, all in pairs. This time we have 2 X's, so XX is female, XY is male. So there are some abnormalities. We know something goes wrong during meiosis. We talked about non-disjunction, which means they don't all come apart appropriately. And we end up with an abnormal amount of chromosomes in the cell. This can lead to several genetic disorders. A lot of times we call it trisomy, 3 somy chromosomes. And they're usually in the autosomal. That does not always happen. Sometimes we get extra chromosomes, the sex chromosomes, but most of the time it happens in the autosomal chromosomes, which are those 22 non-sex chromosomes. So trisomy 13, 18, and 21 are the most common. A lot of times, if you have non-disjunction, the embryo will spontaneously abort, aka it's also known as a miscarriage. So that's what happens. A lot of times these 3, however, will get carried to term, and they will have a genetic abnormality, but they will be a live birth. So let's look at a couple. So here is a male. We have X, short little one, Y. However, on the 21st chromosome down here, we have 3. Okay. So trisomy 21 is commonly called Down syndrome. Okay. So you can see here, and I don't expect you to remember all this, but I do expect you to be able to see an abnormality. Because here we have 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. But when we get down to this 21st chromosome, we see we have an extra one. Okay. Turner syndrome is also caused by non-disjunction. This is where we actually have only one X. So like I said, sometimes it'll happen in the autosomal chromosomes, which are the first 22. Sometimes it'll happen in the sex chromosomes, which are the X and the Y, or the last 23rd pair. Klinefelter syndromes is another one. We have XXY. All right, these are all done by non-disjunction. So at the bottom of the karyotype, you would see X, X, Y, or if we're looking at the Turner syndrome, you would just have X and then a blank. So example, Let me see if I can get rid of this. So here we can see we have an extra X chromosome along with the Y chromosome. And that's it. Really, like I said, what I expect you to be able to do is to be able to pick abnormalities out. I don't expect you to have remembered Klinefelter syndrome and Turner syndrome and all this other stuff, but I will expect you to be able to look at a karyotype and be able to tell if it is normal, abnormal, male, or female. That is all. Y'all have a great day.